All right, so we are back to special right triangles. And as I told you on Friday, today we're going to be doing the harder examples. I wanted to give the harder ones their own day so that we could, spend more time on them. Normally I teach them combined, and kids sort of struggle with the harder ones, so I separated them, and we're going to do them all the harder kinds today. So we're going to start with the 45, 45, 90s. Now remember, for a 45, 45, 90, the leg is whatever length you want it to be. The hypotenuse is the leg times the square root of 2. All right. So for the harder examples of a 45, 45, 90, I have given you the hypotenuse. See, this is on the hypotenuse side, and so we have to find the leg and the leg. Which nice enough is that because it's a 45, 45, 90, we know that this side and this side are congruent. So in other words, x and y are going to be the same thing here. We just have to find it. So here's the process I do. This square root of 10, I'm going to bring it down here, is sitting where the x square root of 2 is. Like, in other words, these are equal. So what it says is we've already multiplied some length by square root of 2, and we've ended up with square root of 10. We have to find the x. So to do that, we have to solve this equation. It's going to take a little bit. We're going to divide by square root of 2 on both sides. And so that's gone over here. So now we're left with square root of 10 divide square root of 2. And now this goes back to what we learned on Wednesday with the dividing square roots. We have to go through that whole long process again, okay? So let's multiply by the bottom on both top and bottom. So we get square root of 20 on top and then square root of 4 on the bottom. This denominator should be perfect. The square root of 4 is regular plain old 2. So I'm going to take it out, put 2, leave my 20 on top. Now we have to simplify the top. 20 himself is not perfect, so I'm going to come over here and do my tree. We can do 2 and 10. 10 is 2 and 5. That's all broken down. So we have a pair of 2's and a 5. Let me do it. 2, 2, 5. That's underneath. This pair of 2's gets to come outside. So we've got 2 square root 5. Okay? I'm going to replace the top with what we just found. Divide by 2. Now cover up square root of 5. He's done. Can we simplify 2 over 2? Well, of course we can. It just turns into 1. So this entire thing ends up being square root of 5. And that's what both of those are. Okay? So this is the process you'll need to do for your 45, 45, 90s. All right? So same thing. Oops, sorry, that's not the leg. I wrote that wrong. We're given the hypotenuse, and we need to find both legs, which we know they're going to be the same thing, but we write it out twice. And so I'm going to do this whole process again, but with the side they gave me. They gave me 2 square roots of 14 this time, and that's going to equal my x square root of 2. So I will divide by square root of 2, divide square root of 2, that's gone. So I've got 2 square root's 14 over square root's 2. Then go through this process. Multiply by whatever's in the bottom. So on top I'll have 2. This 2 is on the outside, so he's just going to hang out there. Why did I write that bigger? He's going to hang out there in front. 14 times 2 underneath gives me a 28. And then on the bottom I should have the square root of 4. Square root of 4 is perfect. Now, I'm going to come up to the top. I need to fix 28, because 28 is not perfect. Let's do 14 and 2 again. That's fine. 14 is 2 and 7. So we had a 2, and a 7 underneath. This pair of 2's gets to come out. So 2 square roots of 7. So this 2 square root 7 is just this portion. I already had a 2 out front. So this 2 and this 2 I have to multiply together. So that is where I'm going to get a 4 square roots of 7 all over 2. Okay, now we cover up square root 7. 4 divide 2, we know what that does, that's 2. So we get 2 square roots of 7. 2 square roots of 7, 2 square roots of 7. All right. So if you're comfortable with dividing square roots, this shouldn't be that bad. Okay, you just have to remember the process that we did. So kind of set it up like an equation. Whatever they give you equals the x square root of 2, and then you just go through this process. Okay. Now let's go look at 30, 60, 90s. Now, as I said on Friday, kind of like a warning, these kinds of problems give kids a lot of trouble. So I'm going to try and explain what we do. Remember the rules for 30, 60, 90. The short leg is across from 30, and he can be whatever length we want it to be. Excuse me. The long leg is the short leg times a square root of 3. The hypotenuse is double the short leg. It's 2 times the short leg. All right. So let's come down here. Now, what makes these hard is that I've given you the long leg, okay? So for a 30, 60, 90, to get a harder problem, I've given you the long leg. That's the long leg. The y is across from the 30 in this case, so that makes him short leg. And then x here would be the hypotenuse. So anytime you do a 30, 60, 90, you always want to find your short leg first. Okay? So we're going to use this long leg to get the short leg. And it looks similar to what we did for the 45s. We're going to take the length they give us and set it equal to the expression that gave us the 20. So in other words, we have multiplied some number times the square root of 3 and ended up at 20. We have to find what that length was. Okay, and let me space this out because I remember this answer needs a little bit more room. So I'm going to space it out. So, same process, but now it's just square root of 3. So I'm going to divide. So I've got 20 over square roots of 3 I have to deal with. Multiply by what's in the bottom. I get square roots of 9 on the bottom. I know square root of 9 is perfect. Turns into 3. So now I stop and ask myself, can I do anything to the top? Square root of 3 is pretty simple as it gets. So he's done. Then I cover him up. 20 thirds, 20 over 3. Can that be simplified? And we think, no, it can't. So this monstrous thing is the length for y. 20 square roots of 3 all over 3. I know it's disgusting. It's a little gross. But sometimes math is gross. We have to leave our answers in gross forms, especially when I say simplest radical form. Even though this doesn't look simple, this is simplest radical form, and I expect my answers written this way. Okay, no decimals. Now that we have the short leg, we can get the hypotenuse. Remember, to get the hypotenuse, we have to take the short leg and times it by 2, multiply it by 2. I have to multiply this garbage by 2. Let me show you what that looks like. It's 2 times this mess. And what's really easy about this, even though it looks hard, what's easy? You just multiply the 2 and the 20 together. You don't even mess with this stuff. Just multiply the 2 front numbers. So that'll be 40 square roots of 3 over 3. Okay? So that's that one, the whole process for it. Let's do the same thing for this last one. I gave you the long leg. So here's 30. Notice that x now is the short leg and y is the hypotenuse. Always do your labeling so that you know which one of these variables is which side of the triangle. Okay, you want to make sure you match them up correctly. So I'm going to take what they gave me, 4 square roots of 21, and equal it to x square roots of 3, and then start my whole process. So I have to do 4 square roots 21 divide square roots 3. Multiply square roots 3, multiply square roots 3. So I have 4. Remember that 4 is outside, so we're just going to leave him outside. He's chilling. And then inside, 21 times 3 is 63. And on the bottom, I have a 9. Leave the top alone. We'll come back to him in a minute. The bottom is perfect. It turns into regular old 3. Then we come up and check 63. Is that a perfect square? And so you go do your checking, or you know from your head, no, it's not. So 63, we have to do our tree on it. Let's do 21 and 3, what we used a minute ago. 21 breaks down to 3 times 7. So I have a 3 times a 3 times a 7 underneath. Here's my 2 3s. They get to come outside. So 3 outside, 7 inside. So remember, this new part I just found is only for the square root 63 part. I still have this 4 out front to deal with. So now I have to do this 4 times this 3 in front of my answers. That has to be a 12, then my square roots of 7, all over 3. Okay? Now cover up square root of 7. He's done his job. He's good to go. 12 over 3. Can we reduce that? Well, sure we can. We know that turns into 4 square root of 7. So this will be 4 square roots of 7 for the short leg. Now y was the hypotenuse. It's the hypotenuse. So we take the short leg and times it by 2. So 2 times 4 square roots of 7. Just multiply the outsides together. So that would be 8 square root 7. Okay? So those are how you do the longer ones. It's that lengthy process of dividing your square root and then doing all that thing we've done for a couple of days now. So make sure we watch this all the way through and you do your assignment. I think there's just 10 problems, just like on Friday, so you should be fine. As always, if you need help, please let me know.